Oh, right. Okay, now let's try this question 33, please. This integrate.
Please, before we start, I will ask a question. In the previous topic, here, we took took it again because of what sign?
Distribution. Sign. Okay, look at here. Means for sine, when we say x is equal to a sine theta. For sine distribution, what is that?
Minus pi
Theta is basically between from negative pi by 2 to positive pi by 2.
Yes.
You know, the negative pi by 2 pi by 2 positive is which quadrants?
First,
And yes,
wait, if there was that, like, so what is the minus pi over 2?
I'm asking from where
Here? Is it here?
exactly. Negative pi by 2 is down and it is pi by 2. So only 1 and 4 work for this, interval.
So this is
This is-
already cosine is positive.
All positive here and here is cosine positive. That's why.
Yeah, so like this only.
Exactly. Only these two. So in 1 and 4, cosine is positive.
Mhm.
That's why you remove the absolute value without negatives. That's clear?
Yes, yes.
So in this case, you have to check which function you are using as substitution. You should remember the targets. Okay?
Doctor, and another question. When it comes to check motivation.
You can come tomorrow.
Tomorrow?
Yes.
What?
At 12 we meet. Okay, so I'm copying here the question 33, please, for your reference. 33 is v squared divided by 1 minus v squared power 5 by 2. V squared v squared divided by 1 minus v squared and power 5 by 2 and d. So just try to put this. The power of 5 by 2. So what do you think? This is which sufficient? Sorry. Huh? Sorry. It is science. Yes, you're right. Go. Only difference is that right now means for x we are using v. V means x. So don't confuse. When you start, let v is equal to a sine theta. So right now here is a how much? A.
1.
A is 1. We have directly sine theta, please. Okay.
So what about the power 5? Do we like change it into square root?
No. Please go and just try to solve this question, please. Start.
This is 8.4.
So as discussed, this is sine case. Yes, we have to do sine theta. Like that. B is equal to sine theta, A sine theta, but A is one, the non-right one. And D, V is equal to
Cos.
sine theta and so integrate V square, sine square. Sine square theta and divide by 1 minus sine square theta. It has power 5 over 2. And then you have dv. dv is cosine. So look at it, I just updated the values, please. So I have done until here. You can please continue and try to complete this question.
Change it to cosine.
1 minus sine square is cosine square, yes.
Same concept.
Yes, it's gone to numeric substitution. But in the exercise questions, there are some questions where no need for substitution. Actually, in exercise, they put the mix of questions. But in exam, I told you, we mentioned use numeric substitution. It means you have to answer by taking a function as substitution, sine, tangent, or sin.
We're not gonna bring like first question in that class. Portrait. The theta was outside and you told us to use the.
Oh, yes, yes, yes.
You can bring.
Okay, yes, please. Will you reach?
The big cosine equal 5.
Okay.
I'm school, school.
So you got secant square theta divided by cosine 4.
And
Sine square and cosine 4. Okay, okay, yes, it's okay, good. Then please try to integrate this one.
you take you.
So what to take as u?
1 minus sine square.
So you have
Change it to cosine.
sine square theta divided by 1 sine square is cosine square theta. It has power 5 over 2 times cosine theta.
Cosine.
And the theta is integrate. This 2 and 2 cancel out.
Cosine.
So you have now sine square theta. Then we have cosine theta, d theta, and divide by cosine 5 power. Am I right, please? Okay. So here, okay, this cosine you can cancel by here. Now. And now we have integrate sine square theta divide by cosine power 4 theta and cos a d theta. All of you are here now? Okay, now we have to integrate. How to integrate this? What we take as
Cosine.
Cosine, because
Because if you take sine, you have the
big stuff.
what's cosine derivative?
negative sign.
We have any sign.
No,
You
no,
can take the negative sign.
Huh?
big sign now.
All you need is square.
Yeah, we use sine square. Because cosine derivative is sine. We don't have sine. It's sine square.
Can we write cosine to the power and have as cosine square times?
And what happened?
It gives identity. What is one?
Yes, please, come on.
If
Do you put sine, do you divide the signs?
One minus one.
What
If you
the?
have, you can separate it.
Then it really, benefit.
It's substitution.
You break the power for
Yes.
science.
Cosine.
You have science.
Take sine square, cosine square, and sine square is tan square, and the one over the tan square is t. Sorry. So we take tan, that's t.
No, but when it's not 1 over sine, it's 1 over cosine square.
Use it combination of
Yes, you're right. So here, as she said correctly, names right sine square theta and this cosine square, right?
Cosine square times.
Cosine square theta times 1 over cosine square theta. Can I break power 4 like that?
Yes.
Now, what is sine over cosine? Tangent. So it is tan squared. So now it's basically integrate tangent square. What about 1 over cosine? Secant square. And this will be 8.3. Now, what we take as u? Yes. Now we take thing as u. Thing theta as u, and we have now secant square theta, d theta is equal to d. So because k is u, so it becomes now u square and dt, and which is now u3 over 3 plus c. Then what is u? U is tangent. So we have now tangent power 3 theta over 3 and plus c. Now you have to put back tan theta. So what is the solution?
theta to be.
So sorry. Yes.
You want that?
So this is sine theta, okay? So basically we need now tan theta value. So sine theta is V. Sine theta means V over 1. Sine theta root is basically V over C. So if you have a right angle triangle, please. So B is V and C is 1. Yes or no? Please don't confuse. V means X. They won't change the name of the V. So this is C, this is V. I need A. What is the root of A? A square minus B square and square root. C square minus V square, you get A. So this is C, this is B, and this is A. Hope you understand. Now, what we need? We need tangent. So if you have right angle triangle, what is tangent theta value? Tan theta is B over A. So my B is V and A is 1 minus V square and square. So please put back this value here now in tangent. V over 1 minus V square square root. So please, this is tan theta. So tan theta, so 1 by 3, tan theta is how much? V over 1 minus V square and square. And
Power cube.
oh yeah, it has power 3. Yeah. So complete power 3. Or you can say V power 3 and 1 minus V square root has power 3. Like that. I think it's better. You can put like that. Do you understand what I did here? So kindly, I just shared with you this question that sometimes during the integration, you have to use the other techniques. So in the last question, we integrate cosine square by using the even power identity. And here, you can see here we got to get here, tan square, secant square. And we took the tan as u. Okay.
I need some amount, please.
Now, this is the, actually we have one more question, I mean, same like that. This is question 33, right? 34 is also same, but actually when you simplify it coming up cotangent cosecant. So we did not take the coordinates question, and that's why. So this is the question. Okay, so as I told you, yes, one question is sufficient from that topic, yes. Now, after 8.4, we have 8.5. We will learn one more technique, please, of integration. Do you know what is that technique? In 8.5? So until now, you have learned by parts. Then you learned higher powers of sine, cosine, tangent, secant. Okay. Then you learned integration by trigonometric substitution. Now we learn one more technique of integration in 8.5. 8.5. Just called integration by partial fraction. Integration by partial fraction decomposition. Any idea about this integration?
You have a plus b of something, partial fractions.
Yes, partial fraction decomposition. Exactly. Actually, this question has two parts. First of all, it has partial fraction decomposition. First of all, we decompose the partial fractions. The first step. Then we integrate. So it has two parts. First you decompose and then you integrate. That's why it means first of all we have to take a review or learn how to decompose the partial fraction. Now, first of all, please tell me what does it mean by partial fraction? Which fractions are called? Here partial fractions must be proper. What does it mean by proper form? Fraction means up and down, it's fine, but we need proper form.
So the numerator is bigger than
Numerator is small.
small.
Yeah. Okay. Check the degree of up. It should be less than down. It means it is in the proper. If it is not like that, so you have to use long division. Exactly, to make it proper. So yeah, that's why in this section 8.5, because in chapter 7 I forgot to discuss that one, where we integrate which topic? It was inverse trigonometric functions. Where I told you there is a up degree is more than down, so you have to use long division. Okay. Also here in 8.5, there are some questions where up degree is more than down. So before to apply this technique, you have to apply long division first. Okay, inshallah we start when we discuss, so we take that question as well. So please, first of all, please tell me how to write the decomposition of the partial fractions. What are the ways? How many ways are there?
There are three.
So can you just tell me one? Okay. So what first thing you should be, keep in mind that the fractions are proper. Proper means up degree is less, down degree is more. Okay, this is understood. If it is not the case, of course, then you use long degree convert. Okay, in the proper. Anyway, that's the little thing. First of all, please, I have to share with you how to write the decompositions. Number one, you can see number one. Let's say you have x divided by square minus. Step one is that, please, whenever you have integration by partial fraction decomposition, for decomposition purpose, the first step is that you have to factorize denominator. Step 1, factorization of the down part. Up, no need. We have no concern about numerator, no. Only you have to check, is there any possibility to factorize denominator? And please note down, it's not the case that you have means the factorization is possible all the time. No, sometimes denominator cannot be factorized. So you keep as it is, please. But step 1 is that try to factorize the denominator if possible. For example, here, is it possible?
Yes.
The denominator factorization? Okay, my first question is it proper? Proper or improper? Yeah, proper, because up degree how much? 1 and down? Yeah, so up is less than down, it is proper, no worries. Okay, means you can start the procedure. What is the step 1? Factorize down part. So if you factorize the denominator, it gives you x minus 1 into
X plus one.
x plus 1. Very good. Okay. This is step 1. Okay. Factorize the denominator. Please. Don't factorize dry up. No, no need. Okay. Step number 2. You have to check after factorization, what is the nature of your factors? How many factors you have, by the way?
One X.
Oh, how many factors you have?
Two.
2, exactly. We have 2 factors. Okay. The first factor, nature, linear or quadratic? What does it mean by linear?
X.
And what does it mean by quadratic?
Quadratic x square.
Linear means what?
1.
Wow. Linear means the x has power how much?
One.
1. And quadratic means the power is 2. So right now, basically, if you look at the first factor, x power how much? 1. Is it linear or quadratic? Linear. And second factor? Linear. Okay, good. Now, please, what is the first case? First case is that if the factors are linear. So how you write decomposition, please? So now, please, just write this one. Now, if the factors are linear, we use only one constant. How many constant?
One.
Only one. And we start with capital A, B, C, D, like that. So the first constant A divide by first linear factor
X minus one.
x minus 1. And plus second constant
B.
B. And divide by
X plus one.
second linear factor. So this is the decomposition. So this is a way to write decomposition if factors are linear. Linear mean power of x how much? 1. Yes. So if you have linear factors, we take only one constant. Please. Okay, the first case, please. Right. Second case. Here I have to put different questions for you. Now, second case. Let's say I have 3 divided by minus 6. Right, so I just put a fraction to you. Is it proper?
Yes.
Yeah, because up degree is 0, it's constant. Down is 3 degrees, so of course up
But
is
in
less.
this case, it's not.
No, please, what is step 1?
Factorize.
Factorize.
Then you have to check please. So step 1, please, factorization possible here? Okay, how I factorize? I take x here as a common factor. Now I have now what?
X minus one.
X minus
Yeah.
X minus. Understand? Okay.
have to make it clean.
Huh?
Have to make it clean.
Now, after taking factors, how many factors we have now?
1, 2.
Factors, please. 2 factors. The first factor x squared, the second factor x minus 1. Understand? So what about their nature?
One is
The first one is
quadratic.
quadratic,
Yes.
and second
Linear.
linear. First one is not quadratic, by the way.
It's the most.
It is linear. How? Actually, you can write this.
As X times.
Yeah, you can write this x square as x times x. Okay, so please. X has power one, means it's the first factor, it is second factor, and then you have third. So in fact, you're not two. How many are there? Three. But please, we have a way, means we can go like that. A over x plus b over x plus c over x minus one. But in that way, it takes very lengthy question. So we have another way, we have another way, please. So don't worry about that. So please, means whenever you have only x and it has some power, so don't say it is quadratic, it is linear. So we treat always this x square because we can break it, x power one, x power one. That's why it is considered as a linear. But please, we say in this topic, we say that this is repeating factor. What do you say? Repeating. How many times x repeating here? Two times. Yeah. So please, when you write that decomposition, this is a second case. Linear factor repeating, okay? So please now write the decomposition 3 over x squared into x minus 1 is equal to 3. How it start? Look at here. X squared is not quadratic, please. It is basically x times x, okay? It's linear, please. What I told you, if you have linear factor, how many constants they use? Only one constant. So look at it. The first constant and x power how much? 1. We have to break the power. Plus second constant. Now this time x has power how much? 2. This is the way to write the repeating factor, please.
But sir, wait. For A, it's X. So
We have to decompose because the topic is decomposition. We have to decompose the powers, please. So first time power 1, second time power 2. Okay, let's say it has 3 powers. How we write the decomposition? A over x power 1 plus b over x power 2 and then plus c over x power. Oh yes, because this x is repeating 3 times. So this is the way to write decomposition for the repeating factor. Yeah, please.
Can this be like, sorry, x instead of the x squared, x minus 2?
And square, yes, look at here, not this one.
No, not the square.
Yeah, it's okay. I mean, this point is the same, but then we're talking about here. That's the difference. This is x minus 1 and power 3, for example.
Yes.
Yes. So just is a repeating factor, it's a linear. Because here, degree how much?
1. So
1 is a linear. It's linear and repeating how many times? 3 times. So a over x minus 1 power 1. Then b over x minus 1 power 2.
square.
Yes. And then c over x minus 1 power 3. This is the way to write decomposition.
For the other part.
Huh?
When we used to have the x squared, for example, and the x minus 1, what happens to the x minus 1?
If you have what?
Like one, like a over x, then b over x squared.
Yeah.
What happens to the x minus 1?
No, then you have again. Here actually this is same thing. You can combine that, but it is let's say now different.
Yeah.
So now you have this now plus d over x minus 1 power 1 plus e over x minus 1 power 2. All are repeating. That the first one repeating 3 times and the second repeating how many times? 2 times. Look at it.
how do you know if you have a repeating factor?
Because you have powers, please, you have powers. Power will tell you repeating.
What was x plus 1 to the 4?
X plus 1,
Yeah, the other.
How do you know it's not?
this one?
Yeah.
Means this is also x plus 1, also x plus 1. So combine them, become 5. Why you are taking and 5? So write 5 times.
Sir,
Become 5. No need for that. Write 5 times, yes. A over x plus 1 power 1, b over x to power 2, c over x power 3, 4 and 5, yes. Yeah, please.
So from A to C, it's just the first one.
Yeah, exactly.
And then from
Exactly. Yes, yes, yes. You're right. You're right. So please, there is not any, difficult thing. It's very simple. Number one case, there is no repetition. And number two, there is a repetition. And that's all. Check the powers, please. Means if you have power, it means it is repeating. So please, again, I'm just giving the simple format here. One thing you have to be, note it down, please. Whenever you have x power, so it's a linear factor, please. Means a 3 divided by, this is a linear factor because x squared means you can write x and again x, please. Okay, so we always treat it x power something as a linear factor, but repeating form, repeating form. Because this x has 2, basically here is 1, so you can write like that. So it is not quadratic. It is the x is a linear factor, but coming 2 times. It is repeating 2 times. Okay, so we put in this category x. It is coming 2 times, please. So x square and then x minus 1, please. So kindly, whenever you have x power 2, don't treat it as a quadratic factor. It's a linear factor with 2 times coming up. So a over x power 1, then plus b over x power 2. And plus, you have one more factor. It's a linear or quadratic. Yeah, means this x power will decide to you. So it's again linear. So we write only one constant c and divide by x minus 1. Yes. So please, this is a way to write a linear factor, please. Okay. If it's repeating, you have to decompose power. Power 1, power 2. Okay, like that.
That's a repeating factor of a quadratic.
No. This is x has power 2. So please,
So you always break.
we can break this one in linear. X times x.
So you always make it linear.
Yes, exactly. We have, means if it is possible, make it linear, exactly. Okay, do you understand this now? Second case, okay. These are 2 cases only for linear factors. For linear factor, how many constants we use? Only one. One factor, one constant. Okay. Now, case number 3. Now we have, okay, see, 2 cases for the linear factor and same like 2 cases for quadratic factor. If the x has degree 2, okay, then comes quadratic factor. How we write decomposition? Okay. So for example, number 3 case. Let's say you have 3x divided by x squared plus 1. Please. Step 1, can you factorize denominator? Of course, no. It's not possible. Okay.
So you stick.
Huh?
You will not change it.
Yeah, we'll see it. Now, please tell me, the denominator factor is linear or quadratic? Quadratic. Now, please note down. If the factor is quadratic, we always use 2 constant. How many constants? 2 constant. So when you start the decomposition, please look at it. A plus B, look at it. 2 constant together. Divide by this quadratic factor. And with A, you have to put what? X. Please. Case number 3 is now when the factor is quadratic. So we always take 2 constants together. 2 constants. And with one of them, we had to put X. So this is the decomposition of this quadratic factor. Hope you understand. Okay, let's take one more example. Not case. Same thing. I just give you an example, please. For example, you have a question like that, please. X squared divided by x cubed plus 1. This is a question, please. Right? Okay, first of all, proper, improper. Proper, up degree is less than down, proper, okay. What step? Next one is, we have factorize, numerator or denominator?
Denominator.
Always denominator. Possible factorization? No.
Yes.
Can we factorize denominator? Yes or no?
Yes.
Can you factorize denominator?
Yes.
Of course, yes. Don't factorize up, please. Numerator, no change. Now, factorize a cube plus b cube. A plus b into a square plus ab plus b square. The sum of two cubes, a cube plus b cube. That factorize.
That's minus.
It's fine.
Yes.
Yes, it's. It is plus. In plus. So we factorize. A cube plus b cube, a plus b into a square minus ab plus b. So don't forget the algebra, please. We have to use. We have to use frequently, please. If you don't know, oh my God, it's like. Okay, now please. After factorization of the denominator, how many factors we got? Two. Okay. First factor nature, linear or quadratic. And second, now you have combination. One factor linear and one factor quadratic. So now we have done already how to write linear factor decomposition. We also learned how to write quadratic factor decomposition. So please now write the decomposition. So x squared divide by x plus 1 times x squared minus x plus 1 is equal to, okay, first factor linear quadratic. How many constant? Only one. So a divided by x plus 1. Okay. Plus next factor is what nature? Quadratic. How many constant? Two. Two together, exactly. So give me the next constant.
Yes. Yes.
So a done.
Plus C.
Bx plus c divided by x squared minus x. I'm just telling you how to write decomposition, how to answer them. It is a next story, okay? Yeah. Because we need A, B, C answer. Please. Not answer, not answer. It's a decomposition. Yeah.
Starting.
No, here. Oh, yes, exactly. This one. This one, not up. This one. This one. First, I factorize the denominator, and then I write the decomposition. It's not the final answer. You need A, B, C.
You need to make it perfect.
No, it's not perfect scale, please. Actually, you have to decompose, break into parts, into pieces. You know why we are decomposing? Why? Because we have to integrate them. At the end, we need integration. That's why. Otherwise, we cannot integrate this so much complicated.
Not they come in not in a proper form, so we.
Exactly. That is something. The next thing means when it's not the proper up degree is more than down. So first we use long division, make it proper. Then we decompose like that.
Then we need.
And then we integrate. If it's not proper, if up degree is big than down, then right now it's okay. Up is small, it's fine. So please, so you understand here? One last, case number 4. But again, is related to quadratic factor of 4.
So Dr. Two linear, two.
Two cases for linear, 2 cases for quadratic. Yes. Now, for example, if you have let's say I have x divided by okay. I have put this question for you. So please tell me, is the factorization possible? Which factor is trying more?
The X cube minus.
This one. Can you factorize this one?
No.
No. This one not possible. This is prime.
X square root.
Factorization, not solve this. This one we cannot factorize more. Is a basically prime. Okay. So. Oh yes, this one you can factorize. Yes, this one you can factorize by which rule? Difference of two cubes, a cube minus b cube. So the first one, no change, not least, no variable, no change.
As it is.
This one, because we cannot factorize x squared plus 1, it has power 2 base. Yes, this one we can factorize. How?
X minus 1.
X minus 1, x squared plus x and plus 1. So now we factorize completely denominator. Down part we have to factorize. Denominator, please. Okay. We factorize completely. Okay. Now we write the decomposition, please. So how many factors you get in denominator? 3. Okay. First factor, nature. Quadratic. Degree how much?
2.
Sorry, not a degree. Means power of this factor how much?
2.
What is mean by this power 2?
2 times.
It is repeating. How many times?
2 times.
So when you write decomposition, first you write power number 1, then you write power number 2. Yes. But it's quadratic. How many constant we take for quadratic? 2. Yes. When you use this factor quadratic, you use 2 constants. This one linear. How many constant? 1. This one, how many constant? 2. So please now write the decomposition, please. So this is x divided by x squared plus 1 power 2. Then you have x minus 1. Then you have x squared plus x plus 1. Now we have to write its decomposition. Please start. The first factor, linear or quadratic?
A over x.
So you have to always check the power of x, please. Huh? Power of x. This will tell you it is quadratic or linear. It's quadratic, good. So for quadratic, how many constants?
2.
2 constants. Start, please. Can you tell me?
X.
Ax plus b divided by x squared plus 1, but power number 1, because it is coming 2 times.
After we're using the repeating.
It's repeating now, exactly. Now plus.
Plus Cx.
Again, you have to write this one with power 2. So, because quadratic factor, 2 constant. The next 2 constant.
Cx.
Cx
Plus B.
plus b divided by x squared plus 1 and power number 2, because you're decomposing its power. Taking power number 1, power number 2. Okay. So this one, the first one we have done. The first one, decomposition is this one. Do you understand? Okay.
Yes.
That the first factor, quadratic, who is coming 2 times, this is the decomposition. You understand? Okay. Now come next factor. X minus 1. Linear or quadratic? Linear. How many constant?
1 constant.
Only 1. You have used A, B, C, D. What next?
E.
E. And divide by
X minus 1.
x minus 1. Hope you understand. We have one more. The last factor, linear quadratic, quadratic. Is it repeating? No. So we take only 2 constants and that's it. So after E, what is the next 2 constant? So we have E, F, X plus G. E, F, and G, and divide by x squared plus x plus 1. So my dear student, please, this is the way to write the decompositions. So I explain in detail how to decompose. In 4 steps, I give you the whole story of decomposition. Not more than that. There is nothing more than that. This is only decomposition.
What's the other x to be?
Huh?
What's the other x to be?
X to where?
How you put it as x minus 1 and then.
No, means you're talking as a power?
No, as inside the brackets.
Oh, no, it's not decomposition. Degree 1, degree 2, plus.
Only.
Oh, only, it is not work. This math, you are talking about the degree 3. Not possible. You cannot. Oh, yes. Sometimes you have to try, like before I put the question,
Yes.
degree 3, look at here. Where is that degree 3?
Oh.
Here, look at here. So you factorize, it becomes a quadratic and linear. Maximum this option. Power 3, more than, no, we cannot answer by partial fraction, no. So I hope, see, the basic things are only two. Number one, if factors are linear, only one constant is. If factors are quadratic, two constant. And just check if they are repeating, decompose their powers. Write power number one, then power number two, like that. Understand? Okay. Now I think it's better to take a question so that you should know after writing decomposition, we need A, B, C. We need the value. So how to find these A, B, C, D, E values? So integration at last. You find A, B, C, D, then you integrate. That's why I told you it has two parts. The part one, you have to write decomposition and find the answers of A, B, C, D, E, F. Second step is that you have to integrate. So let's start the question, please. 8.5 now. So these are the questions, please, from the ebook. From 1 to 8, they only give you practice how to factorize. Okay, so don't put that. Let's start the question from here. 16th question we can start from 16. X plus 3 divided by 2x cubed minus 8x. 16, please. 16. 16. In 16, we have integrate x plus 3 divided by 2x cubed minus 8x. X plus 3 divided by 2x cubed minus 8x. 2x cubed minus 8x. I told you already that in exam is mentioned by using partial fraction decomposition or by using by part, by using trigonometric substitution. So method will be mentioned to you. So here we ask you by using partial fraction decomposition, please integrate. Now, what's step one?
Take x outside.
Factorize denominator. Don't take anything in the numerator, please. So we have x plus 3 divided by, how can I factorize here? I can take 2x upon factor. So I have now x squared and minus 4, am I right?
Yes, please.
Can I factorize more?
Yes.
Oh, yes. So please, continue, please.
X minus 2x plus.
X minus 2 and x plus 2. So x.
Calculated.
Oh, yes, no problem. We need only factorization, that's all. It's up to you how you factorize this. Factorize the denominator completely. Okay? Right. How many factors we got? 3. What are their nature? All the, sorry.
Before you solve, you need to fully work.
Yes. The denominator should be fully factorized. Now, next we have to write their decomposition. Now, please forget about integration because integration will be in the end. So just write only without integration numerator, which x plus 3 divided by 2x. Then you have x minus 2. And then you have x plus 2. If you want, you can write this factor as a fact, no problem. All are linear, understand?
Yes.
Okay, now start decomposition. Yes, please. Linear, how many factors? Sorry, how many constant?
One.
So A over plus B over
X minus.
X minus
plus C over
X plus.
X plus. So understand? we have already learned that how to write decomposition of linear factor. Good. Now I tell you how to find this A, B, C. Means whatever you have in your questions, A, B, C, D, okay? So we have now find out their values. After decomposition, you know what next step you have to do?
Find
Find the A, B, C.
Yeah, but how? Next step.
the zero.
Roots,
So X equals.
Multiply
roots,
multiply both sides.
Where will it just be?
Basically, when you write decomposition, and please, the steps are same for all the questions. Same step. Step number 1, write decomposition. Step number 2, remove the denominators. We need the simplified equation. Means I don't need the denominators, please. So how I remove the denominators, please? Do one thing, please. Do one thing. Please note down whatever you have here. Multiply this factor each and every term. So when you multiply this one by this, so all cancel. The left side is only what?
X.
X plus 3, because I multiply this factor here, all cancel. I have only x plus 3. Okay, now next. When you multiply this factor here,
You have X minus.
what cancel?
2X.
Only 2x cancel by 2x. So with A, what do you have?
X minus 2 and X.
X minus 2 and x plus 2. Now, when you multiply this factor with B, what cancel?
X minus 2.
Only x minus 2 cancel.
You have
So
2X,
with B, what you have?
2X
We have 2x
and X.
and we have x plus 2. Very good. Now, when I multiply this factor with C, what cancel?
X plus 2.
Only x plus 2. So with C, what we have? 2x and x minus 2. I hope you understand.
Doctor,
Please, we need a simplified form. Whatever you have here, multiply here, 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 and here.
And
Yes,
then you
please.
distribute.
no, Doctor, it is like same as finding the value of X plus 3, right?
What is that, please?
Like for an example, it is the same as finding the value of X plus 3.
Yeah, you can say like that. But please, what we did here, whatever here in the denominator, we have to multiply here,
Yeah.
here, here, here. So from here, all cancel your only this part.
Doctor, and then you start solving.
Basically, we say this equation as a star equation. If you want to name it, you can say this is star. This is star equation, please. If you want, I'm just referring. No need for that, but just for my easy calculation, because I will refer again and again star. That's why.
So we must write from this one.
You must write in this form. Yes.
And then you start solving.
Yes, please.
How you make it and
Actually, what I did, I multiply this factor each term.
okay.
Means I multiply here. You can say
Doctor,
I multiply here 2x, x minus 2, x plus 2. Now what happened? This is cancelled. With A, you have only this one. Then I merge here, also here. X minus 2, x will cancel, you have only this one. Then I same thing repeat here. X plus 2, x will cancel, you have 2x and x minus 2. Hope you understand. Okay, now, next step, please.
Solve.
Multiply by x. X. Hello. Hello.
Okay. As we get simplified form, please. From each denominator, we get the x value and put in the star. From the first, factor, from first factor 2x, if you make it equal to 0, put x value. Yes. From okay, from first factor. Make it equal to 0 means what I mean 2x is equal to 0. How much x please? 0. From my first factor, I have get x 0. Substitute 0 in star. Come on. So 0 plus 3 is 3.
B0, C0.
0 minus, so A multiply 0 minus 2 is minus 2. 0 plus 2 is 2. Okay, put here 0. 0 times B, 0. Finish. 0 times C, finish. So from here, minus 2 times A minus 4a.
So we got the zero just from the first.
From the first factor, please. From the first factor, please, make it equal to 0. Every factor makes 0 and get x. I make it to x 0, x get 0.
But from the second one.
X is 2. And from that, x is negative 2. Use 1 by 1.
Then you solve for a.
Yeah, okay. So please, from here, a how much, please?
By negative 4.
Oh, yes. So a how much? Negative 3 by 4. So our a, we get a, which is negative 3 by 4. I got my first constant answer. Hope you understand.
Yes.
Okay. From the second factor, make it equal to 0. What is x value? 2. Now put 2 in star. Now you have to substitute 2 in star, please.
Doctor, why don't you do the same thing?
I just tried the question. But first,
We can do the same thing.
no, before I just told you how decompose. Not I ask the question. Now, first time I am answering the question. That's the answer. Yes, 1 by 1. Even not answer. I just want A answer. I need B. I need C. Then I need integration. Integration. Because the question is integrate.
Doctor, we put.
Okay, now please, from here, please. From here, I substitute x0 in the star. Agreed? Now, from here, x how much? Please substitute 2 now in the star equation. So 2 plus how much? Y is equal to, when you put 2 in here, 2 minus 2,
Zero is all.
this is all 0. Okay, come here. B times 2 times 2, 4. 2 plus 2, 4. Okay, put here 2. 2 minus 2, 0. This whole 0. Finish. From here, 4 times 4, 16b. We need now b. So divide 16. Divide 16. It's cancelled. B equal 5. So b is equal how much? 5 by 16. I got my b also. What is third factor?
Negative.
X plus 2. Make it to 0. So how much x value? X equal how much? Negative 2. From the third factor is from here. X is minus 2. Substitute minus 2 in star. So
Get negative 2.
now please, negative 2 plus 3, 1, right? Is equal to now.
Yeah.
Minus 2 plus 2, 0, finish. Minus 2 plus 2, 0, finish. Now with C, 2 times minus 2 is minus 4. Minus 2 again, minus 4.
Negative.
So 1 is equal to negative 16 times C. What is now? Sorry, positive, you're right. So, and then now we have divide by 16 here, divide 16 here, it's cancelled out. What is C? 1 by 16. Do you understand how we are getting the values? Please, you are using all the factors. Each factor equal to 0, get x value. And put this x value 1 by 1 in star equation. That's why I name it star. Yeah, please. This one? My last value from this fact is minus 2. Put here, minus 2 plus 3. So 1. Okay? Understand? Submit both sides. Wherever in star you have an x, put the x value, please. So you get A, B, C?
Yes.
Okay. Put back A, B, C again, yes. So put here. Put here A value. Put here B value. Put here C value. And then integrate. Okay. So if you don't mind, please, can I please A, B, C right now here? Because my A how much? Minus 3 by 4. B how much? 5 by 16. And C how much, please?
1/16.
1 over 16. So now what I will do now, please? Okay, I can go means I write the next step, don't worry. So now finally, please, finally, as I get my answer A, B, C, A is how much? Minus 3 by 4. Look at here, please.
3 and 4.
Minus 3 by 4
With
integrate dx over 2x. I just put the value of a. A how much? Minus 3 by 4. Minus 3 is constant. I came outside. Okay? 2 is also constant. So 2 times 4. 8. So please, no need for write 2 here. Make it what? 8. Because this is constant, take outside. I already have a value minus 3 by 4 constant. The 4 times 2, 8. Next, what is b value?
5 over
Constant 5 by 16. Keep outside and integrate dx divide by x minus 2.
Could you integrate them to get, oh yeah.
Look at here, x minus 2 is same, huh? Integration. Next, what is c? So plus 1 over 16 because it is constant outside integration and we have dx divide by x plus 2. So please, you can see now then how basically we are proceeding. Now, what is dx by x? Or ln, exactly. So this is now minus 3 by 8 dx or x how much? ln absolute value of x. Next, 5 by 16. What is dx by x minus 2? Again, ln absolute value of x minus 2. Because if you use here substitution, you get du by u, and du by u is ln. Plus 1 by 16. And again here, what is that? ln absolute value of x plus 2 and plus 3, and that's all. So integration we have done. It is called integration by partial fractions decompositions.
Doctor, when we reach the integration, it will be simple.
It is,
It will be simple.
yeah. It depends. Depends on the down factor. Is it easy to integrate or not? For example, right now, the down factor is x minus 2, which is basically du by u, which is ln. That's why you get. Right?
What's the hardest one that you can get?
Tan inverse,
Doctor,
sine inverse.
So you put the trigonometry.
Yes, I told you, you have to memorize 3 rules for inverse trig function and also the derivatives of inverse for the sake of by parts.
Doctor, integration.
That table you should memorize, please.
Doctor, integration and derivative.
What if the power, the numerator is bigger than the.
Yeah, you first you use non-deviation. And then you apply this expression. We have questions. Just wait. Let's take one more question, please.
And one question like this, an example.
2.
So this was the.
One with linear, other is quadratic.
Will you, doctor,
Would be very long, so.
No, we don't give homework from.
Mister, when you get from the long division, will you get?
Yes, we have. Yes, please.
We can have a break after.
No, one more question. One more. We have, now I discuss with you the quadratic factor, please. We have to go for quadratic. I just finished one area. It's very simple. It's very straightforward. No problem at all. This question is not coming exam like that. Very easy.
Which exam?
Exam 2. Okay, now let's take a more motion, please. Not take that quadratic, please. Quadratic, yeah. Then.
I think it was from 31 and 32, we are gonna use the division, right?
Sorry.
It was from 31 and 32, we are gonna use the division.
31, 32, yes, you're right, exactly. This is, no, if power 2, it's 2 to become 4, so.
And the numerator is power 3.
No, it's 3 and it is 4. Square. No, I think it's here.
So don't do the difference.
Here, 33 to 38. Here you can see now. 33, 30, all are improper. Because up is more than down, which is not proper. So here you leave first long division. Then you apply that. Anyway, come back here. We have to Let's start students now. I want something for number of this. Okay, we can go 27. 27. X squared minus x plus 2 divided by x cubed minus 1. So here we got okay. 27 please. 27. X squared minus x cubed. 27. Okay, so this is 27 question, please. Now, first of all, please, what we do? Factorize what? Denominator. So when you factorize the denominator, x squared minus x plus 2 divided by x minus 1 into x squared plus x plus 2 and this. So we factorize the denominator. Now we write the decomposition. You can see now one factor linear, one factor quadratic. So just forget about now integration, only apply decomposition, please. Okay, please. How we write decomposition? First factor
X minus 1.
linear. So a over x minus 1 plus next factor
Dx.
quadratic. So two constant b x plus c divided by x squared plus x plus 1. So step one we decompose, please. Next step, what did it? Last question. We remove the denominators, please. We eliminate the denominators.
Multiply by this.
This factor multiply each and every term. So when you multiply here, for case you only have x squared minus x plus 2 is equal. Okay. When you multiply this factor here, so x must cancel with a what you have. X squared plus x plus 1 plus with bx plus c, what you will get when you multiply this factor here? Only x minus 1. Yes, very good. And you can name it star. If you want, you can name it star equation. Because we have referred the equation for the purpose of calculation. Okay.
Then we solve for x.
Exactly. Factor number 1. What is x value from first factor? 1. Please substitute 1 in star. So when x is 1, please, when x value is 1, so what happened, please? 1 minus 1, 0. Plus 2 is 2. So get now.
Why do you apply the same?
No, because I have to remove this denominator. I multiply this factor everywhere.
The x squared minus x cubed.
Yes, this factor, please.
Not remove that.
This factor multiply everywhere, each and every term. When you put here or cancel, you only have this numerator. If you multiply here, only x minus 1 cancel. With a, you have this one. When you multiply this factor here, only this cancel. So with this one is equal. Only you multiply down one everywhere, please. Now, from first factor, I had x value 1, and I put it here, please. So I have now this side is 2 is equal 1, 1, 1. So it's 3a. You should put 1 here. 1 minus 1 is 0. So a how much is?
A is equal to 2 over 3.
A is equal to 2 over 3. So we get a value, which is 2 over 3. Understand now this?
Yes.
Okay. What is next factor you have?
That's a good.
What is the value of x when you make it equal to 0? What is x value? So that we can use in star.
You get imaginary.
Yeah, so from here, no x value possible. Now, the problem is that we have three constants unknown, A, B, C, and we have got only one, A. So we still we need B and we need C.
Second one.
Low numbers. Like one.
Actually, you can apply this procedure as well. If you want, you can use this procedure. I will give you the procedure which works in all the countries. And what is that procedure is?
Doctor, I think it would be better if you distribute the x minus one into bx and c.
This one?
Yes.
Not now, later on, but not now.
Because it will be bx and then x equals 0.
I understand your point. I understand. But when we integrate, then we do. In integration, we have to like that, which you are telling. It's still the way. For integration purpose, we do like that. But right now, because we need B and C value also. So what we do now? Because from this factor, no x value possible. Do you understand the points? Now, the problem is that from this factor, x squared plus x plus 1 equal to 0, x value is not possible. You're getting imaginary iota. So how we get B and C? So to solve this problem, do one thing, please. Let me erase. I need a space, please. By just okay. Keep in mind A how much 2/3. Okay, we have A value. Okay. Now because we need B and C also, so what you do, please? Expand star equation. Open the star, please. So x squared minus x plus 2 is equal to ax squared plus ax plus a plus bx squared minus b plus cx minus c. I expand the star equation. I simply multiply. I open it. Understand? After expanding the star, please, you have to arrange. Arrange means x squared minus x plus 2 is equal. Okay. Now I will arrange my right side. Do you know how to arrange?
Just from higher.
Arrange means what is the highest degree here? 2. So please, degree 2 first,
So
then degree 1, then degree 0. Understand? So please look at here. Highest degree how much? Okay, right here, highest degree x squared. And now in the bracket, how many are there with x squared, please?
A and B.
A
Doctor,
and plus B.
B, yes.
then we
Okay.
take them as common factor.
Exactly. Plus, after degree 2, degree 1.
B on A plus B.
A and C.
C.
Bx squared and minus
Yes.
bx. Oh, yes, you're right.
Okay, B, A, B, C.
Okay, so I have A and with
Minus B.
minus B and plus. Now, degree 2, degree 1, what is next? Without any x.
A and
A and
So we
minus
have
B.
A and minus C. A and minus.
C.
X is here. Now, last, no x, please. Understand how we arrange?
Yes, doctor.
Degree 2, please separate up. Then degree 1, then without any x, please. Degree 0. Okay. Do you know after that how to make calculation?
Yes, we got
Make the
X.
yes. Basically, now we compare the coefficients.
Yes, I remember we wrote A, B, C.
Look at here. This degree how much? 2.
Square.
What is the coefficient here? A plus B. Other side is a degree 2. What is the coefficient here?
Also,
If nothing here was that.
you took the same power together and you took them as a common.
Yeah, exactly. Yes. Now, okay. Right side, x square coefficient is how much? A plus,
A plus B.
left side, x cube of how much?
1.
They are equal. So 1 is equal A plus B. Same degree coefficients are equal.
Okay.
We have A. How much A by the way? 2/3. I think, am I right?
Yes.
Okay, move this side. 1 minus 2/3 is B. 1 minus 2/3. How much please? 1/3? 1/3. So you have got the B. B is 1/3, please. B is 1/3. You got A, you got B. What left now? C. Okay. Look at it, please. For C, which factor has C? Second. And also here, who is more easy? The last one?
Yeah.
Okay. The last one has constant, no x. Do you have any number other side who has no x, only constant?
Two.
Yes, so constant is equal to constant.
Is equal to 2.
Yeah, you're right. So constant is 2. So 2 is equal to how much? A minus C.
Equal to 2.
Degree 2 equal degree 2. Degree 1 equal degree 1. Constant equals constant.
Now A is 2/3.
So A is 2/3.
Then you take to the asterisk.
Yes. So 2 is equal to 2/3 minus C. Move 2 by the other side. Or you can move C to the other side. It's positive. So 2/3 minus 2. Is that how much 2/3 minus 2? Minus 4/3. So finally, my C is minus 4/3. Have you got all constants? A, B, C?
Yes.
But you understand this procedure which I told you? Make the arrangement and degree 2 coefficient, degree 2 other side. Degree 1 coefficient, degree 1 other side. Constant equal constant.
Can you repeat how did we get the
A actually by the first factor means from here x minus 1 you make equal to 0. How much x? 1. So put 1 in the star equation. That's it. Put 1 in star and solve star equation. Put 1. 1 minus 1 0 2. So 2 is equal to look at it. 2 is equal to now 1 plus 1 3 1 minus 1 0. So from here you have 1 is equal to 2 is equal to 3a. So 2 is equal to 3a and then we got this. I get this one. So it's a is 2/3. Please, sorry, yeah.
Can you just hold on a second?
Yeah, actually this method works somewhere and sometimes not. So I gave the method which works everywhere. But you can use this one, it's fine. It's okay. Please.
So why did we like take the 2 with one of the 2 brackets?
I don't understand.
You said that choose either the second or the third one.
Ah, yes. Means actually after A and B we have C. C is also here. This factor is for what? Degree 1?
Degree 1, yes.
What degree 1 other side?
Minus 1.
Minus 1. So if you are using this one, so how to write the equation means minus 1 equal A minus B plus C.
We chose the A minus C because it's easier.
Exactly. If you use this one, you get same answer, but same answer. But it's better, it's small, it's easy. That's why I select this one. But you can use anyone. No?
Because if there is, for example, if there is no C, خلاص,
Exactly. Then we don't need. Yes, you're right. Yes, please.
No, now when x equal to 1, we substitute all.
The star equation, yes. Left side, right side. All, please.
But we didn't write it because it's equal to 0. And
Yes, because when it's clear 1 minus 1 is 0, so it's 0. Yes, you're right. Save time.
Yes.
That's why. Okay. So now please you got A, B, C. Now it's time to integrate. Now I make integration now. So please, I'm sorry. Now here, this is our equation. Put here A, put here B, put here C, and integrate. Exactly. So what is A, please? So 2/3 integrate dx over x minus 1. I'm just putting here this. Okay. Now we are using the value a, b, and c. Okay. What is b, please?
1/3.
Okay, look at it, please. Plus integrate 1/3x, because look at here, bx, huh? And plus c. See how much? Minus, sorry, not plus, minus. So this is minus how much? 4/3. And divide by what? Look at here. X squared plus x and plus 1. And this is dx. Do you understand?
Doctor, we can't take anything outside.
Right now, no. Right now, no. I just put the values of b plus 10 times x, then plus c, and divide this one. Look at it, please. From here to here, you understand all of you? Good. Now, one thing you have to keep in mind always, please. I'm just giving an advice, please. Whenever you have bx plus c, please, and you integrate, always break it. This over this and minus this over. Always break it. Otherwise, you stuck in integration. It's possible, but become very complicated. So to make the integration easy, whenever you have bx plus c, or mean two constants together in your question, when you integrate, please break in two parts. It's very easy. What is bx over x minus 1?
Left and right.
Yeah, ln. This is done. Finished. No problem. This is 2/3 ln absolute value x minus 1. Understand? What I told you here? First, you have to break. So 1/3 is constant. Outside, it is x dx divided by x squared plus x plus 1. Understand? This over this. Then minus 4/3. Integrate dx divided by x squared plus x plus 1.
Yes.
Do you understand what I did? I just break
It's the same thing, other
this over this minus this over. Look at this.
You substitute.
Now, please tell me, do you understand how I break it?
Yes.
Very good.
Yes.
Most time. Okay. This one. This one, just wait, please. I can, give the integration. First of all, come back here. This finish. This we are getting out. Now we have indeed this and that, please. Okay. How to integrate the last part, please?
And then
No, no, please.
You substitute.
Here, this one?
As well.
First we make here completing square, exactly.
then you can use that.
Okay, please. So this one, please, x squared plus x plus 1. First we apply here completing square, exactly. So
We'll make sure that
becomes x squared plus x plus I think 1/4, right?
Yes.
And plus 1 and minus 1/4. Okay, so it becomes x plus 1/2 squared, and here 1 minus 1/4. How much?
Zero.
Positive?
Yes.
Yeah, 0. This is my completing square. We have done many times, so I went directly. You can check, please. So now, please, I'm just focusing here. This one, we need something. Yes, first this one, please, because this is more important. I have to tell something here. Anyway, just like this one, same. 2/3 ln absolute value x minus 1 plus 1/3. Okay, we can do something here also. How we integrate this part?
Will it give you the value?
Huh?
It won't give you the value.
I'm asking, can you start any solution?
You substitution. We cancel the
What I take as u?
x squared plus x plus 1.
What is the derivative of x squared plus x plus 1? 2x plus 1. Do you have 2x plus 1 up?
No, we have the x.
We have the X, we can.
Yes, we have given.
I need the derivative of denominator is 2x plus 1. Do you have 2x plus 1 up? No.
2 and
Okay, I guess.
2 and half.
Come on, please. Means here Right now, this solution not possible because when you take x squared plus x as u, its differential is 2x plus 1. Up is not 2x plus 1, it's only x. Do you, is that point? So we make it, we have to add, subtract something to make it possible. First of all, the missing thing is what? 2x, sorry, 2 missing, right? So multiply 2 up and down. Understand? Then, what is missing then? 1 is missing. So you add 1 and you subtract 1. So,
You can see that x and x. When we substitute that, so 2x plus 1, 1 over 2x plus 1, that is x, yeah? You cancel the x.
no, right now, please. You have here, look at it, please. X squared plus x plus 1 is equal to u, okay? Now, please look at here. Now, drive here. 2x plus 1 dx is equal to du. I need this one, please, in numerator.
Okay, 2x.
I don't have. Okay, 2x possible. 2x here and 2 here, it is fine. Okay.
We need plus 1 as well.
Of course, then this is my requirement.
Plus 1 minus.
Plus 1.
Ah, yes. Now what do we do? We add plus 1 and then we subtract minus 1. Okay, so here in numerator, please. That's why I said spending. Can I add 1 and same time I subtract 1 is possible?
Yes.
Yes, no, not the maybe. You should sure, yes. If you're adding something to make balance, you have to subtract something. Okay.
Yes.
Now, I'm just okay, please. This one is here. This one, sorry, this one is here. Okay. Actually, that's why I don't want to mess up. That's why I just finish one and then I come back to here. Huh? Anyway, because we are discussing is fine. Now, 3 times 2, how much, please? 6. Okay, so this is 6. It's okay. Now integrate this. Now you have 2x plus 1. Am I right, please? Then you have minus 1. And this is basically x squared plus x plus 1. And it is dx. So please, this one I wrote in that way. Is that okay, please, all of you? Good. Come now, this one, please. I told you here, what you have here? Completing square. Understand? So you have minus 4 by 3. Integrate dx. And now it becomes what? X plus 1 by 2 square and plus square root 3 over 2 square. If you don't mind. Can I write 3 or 4 like that?
Yes.
Can I write 3 by 4 like that, please? Yes or no?
Yes.
Do you know why I make this one like that? What? It is 10 inverse. That's why I made it. And that's why I told you memorize inverse trigonometric functions rule 7.6. 3 rules for inverse integration and 6 rules for derivative. Derivative, inverse derivative you need in by parts. Please.
These are the
And-
things. These are the only.
Only 2 tables you need memorize in exam. Otherwise, the rest no need for it. This is a square plus u square. It is 10 inverse. What's the formula? 1 over a. What is that? Please check.
1 over 8.
10 inverse x over a. Exactly. So, please look at here now. This is 2 over 3. And then absolute value x minus 1, please. This one is pending. Okay, now how do you integrate this one now?
Split.
Right now, look at here. You have to break. Why break? Because only this part is working for substitution. Only this one. Please. This 2x plus 1 is only working for substitution. Please. So you have to break. Means look at here. 1 over 6 integrate 2x plus 1 divide by x squared. Sorry. X squared is x squared plus x plus 1 with dx. Then again, split again plus 1 by 6. I'm sorry, it's minus sign, minus, yes, it's minus, no worries, minus.
Just make the example.
Integrate dx and divide by x squared plus x plus 1. Do you understand how I break into parts?
Yes, yes.
This one, please. 2x plus 1, I break, please. This over this, minus this over this.
Okay, integration of this, we know. What's
This one,
Like this.
it's same, it's same.
Sir, there will be 10 months for this question, right?
Try to understand, see, you do not put some, let's see, question, you have to maybe, one of the component become part of your exam. You should know how I go, okay?
Yeah, but how many months for this?
18 marks, okay. Come on, please, this one, please. Minus 4 by 3. Okay, please, come on, first of all, finish this one, please. This is, I told you already, this is equal to what? A squared plus U squared, which is A inverse.
Yeah.
How you write the answer? 1 over A. Square here.
Square root of 3 over
1 over A, get here, 1 over A. It's Philip.
2 over square.
1 over A, tan inverse, x over A. Your x how much?
X plus
X plus 1 by 2 divide by A, which is root 3 divided by. This you can copy paste here, please. Because this is same thing which you did here. It is x squared plus x plus 1, the same thing, x squared plus, because here we need again completing square method. This one, this one here, copy paste same. Don't do again, please. This one, please, copy paste it like that. So now, the last thing here, how you do this one? Yeah, it's a U sufficient, which is ln, exactly. So please write directly answer. So this one, 2 over 3 ln absolute value x minus 1 plus 1 by 6, and it's ln exactly. Ln of x squared plus x plus 1 minus 1 by 6. This one, please, this one you can make the, completing square method, which is this one. X plus 1 by 2 squared and plus square root 3 by 2 squared. Do not calculate again. You have done already this calculation. Just copy paste. I'll just copy paste here. Yes, please.
What's the difference between this one and the one before?
This one and?
Oh, never mind. Yes, it's using station.
Yes, that is fusion.
Yeah.
It's the tan inverse. Now here, please, flip it, please. 4 by 3 times 2 over root 3. Am I right? And it's tan inverse, please. This is the angle means value. So tan inverse, please. This one also you flip it, please. So it becomes now 2 times x plus 1 by 2 divided by square root of 3. I just flip it, please. Look at it. And this one answer is same like this one, please. So just copy paste this answer here. No need for anything. And finally, please. And this is 2 over 3 ln x minus 1 plus 1 by 6 ln x squared plus x plus 1 minus 1 by 6. Now please look at here. This one, I just copy and paste this part, please. Because they are same, please. They are same. I just copy here, please. So how much this one, please? 2 over root 3. 2 over root 3. Tangent inverse 2 times
I'm just making it up.
x. Yes, we can make it 1. Yes, this is possible. It is possible. And now write finally this one. 4 times 2. 8 over 3 root 3. And tangent inverse x plus 1 by 2 divided.
Conceptual. These are the same.
Yes, yes, we combine, of course. Means this is you can 2 and 6 cancel out. Look at here, this one. You can make it as 3 root 3. If you take the answer, in the answer, they combine these two. They are same. Here, 2 over 3 root 3 and 8 over 3 root 3. So you can combine them. Minus 2, minus 8 become minus 10. Here? Ah, yes. So I cancel.
If you bring this question in the exam, I'll stop until integration.
Integration.
That's
Integration you have to do or? No.
okay. Before, stop there. That's my list.
See, actually, of course, we not put this so much in the question. But in this question, there are some components which make the part. For example, as I told you, if you have here,
Doctor, we use 5 techniques.
if you have here, so how you integrate? So you have to use the operating square. Understand? So that's why it means I make it part of the calculation. Anyway, this and this, you can combine them. I think becomes -1 minus 9 by 3 root 3. Then minus 9 cancel. I think it comes 3 over root 3. 3 over root 3, something like that. Take on factor this one. If you take this one as common factor,
That time at the.
3 minus 3 over root 3. Yes. Negative only means if I take here, I take the common factor this one. If I take negative sign and then inverse 2 times x plus 1 by 2 over root 3. If I take the common factor, it becomes 1 over 3 root 3 and plus 8 over 3 root 3.
Okay.
It becomes 9. 9 over 3 root 3. One cancel out becomes 3 over root 3. Yes, exactly. This one will give you now. Finally, it gives you here.
I can't just do the
Oh, yes, you can do it. You can becomes here 3 over. So if I combine, I get it. And you have 2 more answer here. This is 2 by 3 ln minus 1. So 2 by 3. 2 by 3. Then we have plus 1 by 6 ln x squared plus x plus 1. Okay. Okay. Oh, we get the answer.
Oh, so we combine the elements?
This and that?
no.
No, not possible because they have here coefficients. And even this is.
Why it does one?
It's okay. No need. It's not possible. Because. Yeah, plus. If I take this as a powers, and then you can write as a product. So it's not actually high.
This is the most provider.
So anyway, this is the partial fraction decomposition 8.5.
Very good.
No, we take more questions, please. We have, for example, next class. So next class we go. Because here also we have to use long division.
Bring this thing.
Doctor, cancel it. Like previous info.
What?
Yeah.
Don't bring it.
No, we have 2 questions over here.
Don't need it.
Very good.
That's saying, this is not a question in the exam.
No, long. The questions are the same.